Hello everyone, my name is Arun Basavarajalur. In this presentation, I'll be demonstrating my project, Heart Attack Risk Prediction using AWS Cloud Services. The goal is to build intelligent health monitoring system that can predict heart attack risk in near real time using cloud Amazon Cloud ecosystem. This solution connects data ingestion, big data processing, machine learning, and automated alerting into a single workflow that could easily scale in the real healthcare startup. Uh, the architecture moves data through these AWS services, S3 EMR, a SageMaker, Lambda SNS, and Athena. Data starts in S3 and gets processed in EMR, modeled in SageMaker, automated through Lambda and SNS, and finally analyzed with Athena. Let's walk through each step to see how the system works from raw data to predictive insights. So the project starts in Amazon S3, which acts as a centralized data lake. I created a bucket named Healthcare Project Data Arun Basavarajalu and organized folders for raw, processed, and prediction and alert data. The historical data set, I picked this data set from Kaggle, contained patient demographics and existing health metrics. To make it more dynamic, I generated another file, simulated underscore vitals.csv, which mimics wearable device data such as heart rate, sleep, activity for 20 patients across 7 days. This setups gives the project a live data feel, preparing it for a large scale ingestion in a later phases. Once the data is in S3, I launched an EMR cluster named Arun Basavaraj Alur Health Data Processing Cluster. Using Apache Spark on EMR, I processed and merged the simulated vitals with historical datasets. The Spark job calculates weekly averages for a key vitals such as blood pressure and heart rate and aggregates activity levels and output the clean dataset back to S3. The output dataset contains one row per patient with summarized weekly health metrics, making it an ideal machine learning in a SageMaker. In SageMaker, I trained a predictive model using XGBoost algorithm. I created a notebook instance named Arun Basavaraj Alur Heart Attack Prediction and loaded the processed dataset from S3. I pre-processed the data by encoding categorical values, splitting it into training and test sets, and saved the feature list for a consistent inference later. The model was trained with the AUC as a performance metric. Once the training was complete, I deployed the model as a real-time endpoint called XGB Heart Attack Endpoint Arun timestamp. This endpoint allows the Lambda to send the new vitals and receive the risk prediction instantly. To automate the prediction and alerts, I created a Lambda function named Arun Health Monitor function. This function read new prediction files from S3, evaluate risk levels, and sends alert through Amazon SNS, that is simple notification services, when a patient score exceeds 0.45. Every time a new file lands in a prediction folder, Lambda automatically runs and notify the doctor via email. This makes entire system event-driven architecture follows the event-driven architecture with no manual checks required at all. After generating prediction, I used Amazon Athena to run SQL queries directly on S3 data. Two tables were created, one for processed vitals and one for processed results. From there, I ran analytical queries to identify trends such as the number of high risk patients, average risk by age group, and how sleep duration correlates with the predicted risk. Athena helps to visualize how lifestyle metrics relate to heart health, turning raw prediction into actionable clinical insights. To summarize, this pipeline represents a real world healthcare architecture that continuously collects, uh, analyzes, and responds to patients' data using AWS cloud infrastructure services. The workflow integrates big data processing, machine learning, and automation to support preventive healthcare. Through this project, I learned how to manage end-to-end workflows across AWS infrastructure ecosystem, ensuring data moves seamlessly from ingestion to production to actionable alerts. Thank you for watching my demonstration of heart attack risk prediction system. This system can easily scale to a support real-time hospital analytics or even national-wide health monitoring initiatives. Once again, I am Arun Basuraj Alur, and this concludes my presentation. Thank you.